Okay, now let's proceed to question number 4. We have Haber process here. Suppose the feed to a continuous reactor consists of 100 mole per second of nitrogen, 300 mole per second of hydrogen, and 1 mole per second of argon. Given a fractional H2 conversion of 0.6, calculate the outlet flow rate of H2, the extent of reaction, and the outlet flow rates of N2 and NH3. So before we solve this question, we need to go back to our previous lecture where we have this formula where fractional conversion F equals moles reactor over moles fed. Since we know that the fractional conversion of H2 equals 0.6, where we can do like this: F H2 equals 0.6 equals NH2 reacted over NH2 fed. This is the formula that we obtained from the lecture notes just now. Then what we can do now is we can find the number of mole of H2 reacted, okay, equals 0.6 times with NH2 fed. NH2 fed is given in the question, okay, where this is the number of mole of H2, the molar flow rate of H2 in feed. So we have 0.6 times with 300. Then we get 180 mole per second. Okay, now let's look at the extent of reaction for each component in the reaction, where we have a negative epsilon for N2, negative 3 epsilon for H2, and plus 2 epsilon for NH3. Okay, since we have H2 reacted 180, and then we know that this is the intermediate value before we can get the final value or the remaining H2 in the reaction. So we can use this extent of reaction, which is minus 2 epsilon, okay, for H2 equals 180. Okay, like I said just now, epsilon is the what happened during the reaction, I mean the intermediate value, okay. Before we get the final value, we have the initial value, right? So the epsilon or extent of reaction is the intermediate value, okay. So we find the value of extent of reaction, where we have 180 over 3, sorry, this is 3, okay, this is 3. Okay, so epsilon equals 60 mole per second. Since from the previous calculation we already know that the extent of reaction is 60, epsilon is 60. Okay, so what we can do here is we solve this question by using extent of reaction. Okay, minus 3 epsilon, then plus 2 epsilon. Okay, so here 100 minus with 60 is 40. 300 minus with 3 times 60, right? Because we have epsilon 60, then we know that 3 times 60 is 180. So 300 minus 180, we have 180 and 120 here. Then last but not least, we have 2 times with 60. Okay, we got 180 for NH3. So from the question we have calculate the outlet flow rate of H2. Where is the outlet flow rate? Okay, then the extent, which is epsilon equals 60, the outlet flow rate of N2 and NH3. So N2 is 40 and NH3 is 120. So this will be the answer for this questions.